This video, I'm going to prove the following fact. For any positive integer n, the summation of n over d times sigma of d, as we sum up over all divisors of n, is equal to the sum of d times tau of d, where d is the divisors of n, and that's what we sum up over. Before we get into the proof, I'd like to ask you folks to subscribe to my channel, especially if you like seeing mathematical proofs, as this is all that we do here. Okay, now the only function in each of these summations are sigma of d and tau of d, which are multiplicative functions. It's enough just to show that this statement here, or this equality, is true, where n is just p to the k for some prime p. So let's write that up. Since tau and sigma are both multiplicative functions, it suffices to prove the above fact for n is equal to p to the k, where p is some prime. So let us look at what we really want to show then, because we kind of changed it a little bit. Now, in the first summation, n over d times tau of d, we are summing up over d values. Sure, which d values? The divisors of n. That is, this summation has nothing to do with n. So I can pull it out in front. And our n happens to be p to the k. So it's really just tau of d over d that we're summing up. Tau of d over d. And this is going to equal to the summation of d times, that should be sigma, I apologize, it always was sigma. Says so right here, sigma of d times tau of d. I modified it a little bit. Well, actually, I want to make two more modifications. I mentioned it, I just didn't do it. n is now p to the k. So this is what I want to show. Okay, so p to the k times the summation of sigma of d over d over all divisors of p to the k. Well, this p to the k factors out in front. Then we have sigma of the sum of the sigma of the divisors of p to the k over those divisors. All the divisors are 1 and p squared up to p to the k. So we get this plus sigma of p over the divisor plus sigma of p squared over that divisor plus sigma of the divisor p cubed over p cubed, all the way up to sigma of the divisor p to the k over that divisor. now what we do is we find out what sigma of these values are. Sigma of 1, it has only one divisor, 1, and when you add up those divisors, you get 1 over 1. The divisors of P are 1 and P, so sigma of P will be the sum of those divisors over P. The divisors of P squared is 1, P, and P squared. And sigma of P squared just requires us, by definition of sigma, to add up those divisors. That should be P squared. Plus 1 plus P squared plus P cubed. Because those terms are the divisors of P cubed. And that gets divided by the divisor P cubed. All the way up to sigma of P to the K. Well, I'm going to add up all those divisors of P to the K. 1P squared up to P to the K. And this gets divided by P to the K. So now what I'm going to do is, let's see what we should do here. Let's distribute the P to the K. So now we get P to the K, say, over 1. I'm going to keep the 1 plus P, but P to the K over P is P to the K minus 1 plus 1 plus P squared. And once again, P to the K over P squared is P to the K minus 2 plus 1 plus P squared plus P cubed. P to the 3 goes into the P to the K that I factored out in front. P to the K minus 3 times. All the way down to 1 plus P, all the way up to plus P to the K, and P to the K goes into P to the K 1 time. Okay, so I'm going to erase the 1 at the beginning. I didn't need that. Okay. Now, let's see what we have. We have P to the K plus, let's multiply this out. P to the K plus P to the K minus 1 plus, let's multiply out. P to the K minus 2 plus P to the K minus 1. Now, let me just write it in the other order. That product is P to the K. That product is P to the K minus 1. And that product is P to the K minus 2. Plus, distributing, we get P to the K plus P to the K minus 1 plus P to the K minus 2 plus P to the K minus 3. Dot, dot, dot. 1 plus P all the way up to P to the K. Well, what happens here is we only have one time. And how many times do we have the number P? 2 times. The term before is going to be P plus P squared up to P to the K. There's only 2 terms that have a P. And there are 3 terms that have a P squared and 4 terms that have a P cubed, all the way up to all the way up to k plus 1 terms that have p to the k. Okay, so now we're in a good position. We want this to equal that. We want it to equal to the divisor times something. Well, let's not worry about 1 for a moment. We have, this is TP times tau of P, which is 2, plus this is P squared times tau of P squared, which is the 3, plus P cubed times tau of P cubed, which is 4, all the way down to P to the K times tau of P to the K, which is K plus 1. And this 1 is like 1 times 1. This is 1 times tau of 1. Tau of 1 is 1. Well, this is the summation. Well, the first thing are the divisors. It's the divisors. And then whatever this number is, we're taking tau of this. Sorry. Whatever this divisor is, we're taking tau of it. This is P, tau of P. This is P squared, tau of P squared. P to the K, tau of P to the K. So it's going to be D times tau of our D. And we're going to do this over all divisors of P to the K, which, by the way, are 1 and P squared, all the way up to P to the K. Exactly the list of divisors that I'm using. Okay, and this is what we wanted to show. We wanted to show that this is equal to that. That's exactly what I said that we wanted to show. And I did it. That means the proof is done. If you like seeing mathematical proofs like this, consider subscribing to my channel, as this is what we do on the channel. We do mathematical proofs. Once again, subscribe to my channel, click the like button, please leave a comment. See you guys in the next video. Watch and learn.